So B is, oh, it's erasing. So B is, the final is at 4 minus a minus 6 over the time, which is 5 minus a 3. Okay, so 10 over 2, which is a 5 meter per second. So it's a positive gradient now, as expected. And then at C, there is no change in displacement. The final displacement is the same as the initial displacement, which means that our gradient of C is just 0. And for D, it's going down. So D is, let's see, the final is at minus 1 minus a 4, oops, minus a 4 over the time. The time is at 8, started at 7. So it's a small time frame, 8 minus 7. Oh, I can't write suddenly. Okay, so it's a minus 5 over 1. So it's a minus 5 meter per second, which is a negative velocity. Okay, so let's answer the question now. The particle moves at a velocity of what? Minus 2, right? For how many seconds? That occurred for like 3 seconds. So A, from this part to this part, it was minus 2 at section A, and it occurred from time 0 to time 3. So it happened over 3 seconds. Then moves at a velocity of section B is, the velocity is positive 5. For how many seconds? We calculated that already. It was 5 minus 3, which is 2 seconds. Okay, so B occurred at this point. A occurred at this point. And C occurred from 5 to 7, which is just 2 seconds. It is stationary for 2 seconds, right? And finally moves at a velocity of, which is our D gradient, minus 5. And the time, the change in time that we calculated was just 1 second, which is over here. Okay, so we calculated that. That was good. Next one. Okie dokie, next question. A bullet is shot at ground level vertically upward at 19.62. Two information here. For the whole motion, sketch its displacement. So if we were to imagine how this bullet looks like in the real world, it would go up, right? It would go up and reach a point where its velocity becomes a 0. And then it has to go down, right? Because that is what happens when something goes up and it has to fall down. Why does it fall down? Because we have gravity. In case you haven't noticed, we have gravity, okay? So A equals to minus 9.81. That's pretty amazing. Okay, so it goes up, it goes down. So our initial velocity is U and our final velocity is V. At the maximum height, our velocity is equal to 0. How should I look at this picture or this diagram and determine what my displacement is? So to do that, to help you see that, I'm just going to label this as the ground level, right? The ground level, we can say that this is 0 displacement. 0, okay, let me just say x equals to 0. And then, which means that as we go up, our x increases and reaches a maximum height, and then it goes down again. It never becomes negative, right? Because our ground level is defined as x equals to 0. Okay, so we started at x equals to 0, right? Displacement equals to 0. So displacement is 0 at time 0. Is a 0. Okay, so I'm going to divide this into few times. Let's just say 1, 2, 3, 4. Let's just do that first. And then I want to calculate the displacement. Alright, let's do that. So the equation for displacement is S equals to UT plus 1 over 2 AT squared, right? And we know what A is. It's the gravity. And we know what U is. We just need to plug in the time to know what is our displacement. Okay, so U is 19.62. It is a positive because it's going upwards. let's calculate for t equals to 1 first. So 1 plus 1 over 2 minus 9.81 times 1 squared. So that will give you what? S1 equals to 14.715 meter. I usually tell my students just give me 2 decimal points and that will be enough. And then let's calculate for time equals to 2 seconds, which is 19.62. 2 plus 1 over 2 minus 9.81, 2 squared. And this is, if my calculations is correct, so you get a 19.62. Okay, so you're increasing in displacement, which means that we are still in this section, right? We are still going up. My displacement is still going, is still increasing as my time increases. Now what happens at time equals to 3? Let's just do it. Let's just entertain ourselves. 19.62, 3. Let me do this quickly. 9.81, 3 squared. And this is, what is it? 14.715. It decreased. So let's try to plot that first. So at time 0, it's a 0. The displacement is 0 because we are at ground level. At time 1, 19.62, and this should be around 10, this should be around 15, this should be around 5, okay? So at time 1, we were 14.715. 14.715 is close to 15. This is just an approximation first. And then S2, 19.62. So at S2, I increased in displacement. And then at time 3, I decreased my displacement, which is the same level as my time 1. Can anyone guess what happened at time 4? So let's calculate that just to be sure. So at time 4, my magic skills told me that S4 is indeed 0. Shocking, right? So at time equals to 4 seconds, the bullet reaches the ground back again. So that was the end of the life of the bullet. Pretty sad, but it's okay. And remember, I didn't teach you this, but our equation is S equals to ut plus 1 over 2 at squared for displacement, which is actually a parabolic equation. A parabolic equation with a negative acceleration gives us an inverted parabola that looks like this. So let's try to do the velocity time graph now. Okay, hello. I put back this velocity time graph here. Okay, so we know that at our maximum height, which occurred at time 2, our v is equal to 0, right? So let me just put it there. So that this is time 1, this is time 2, this is time 3, this is time 4, this is in seconds, and this is in meter per second. Okay, so at time 2, it became a 0, and at time 0, it was 19.62, right? Because that was the initial velocity, and it was a positive. And then at time 1, we don't know what it is. And then time 3, we don't know. And time 4, we don't know. We only have this information because we already learned this part. V equals to 0 at the maximum height, which happened at time equals to 2 seconds. Okay, I'm going to try to do this quickly. So equation for velocity is V equals to U plus AT. Okay, and we have this 19.62 plus our acceleration is 9.81 due to gravity. And let's find out what happens at time 1. So this becomes 9.81. It's still a positive meter per second. This is at time 1. So at time V2, we already know it's a 0, and at time V3, we don't know. So let's just try to plug in the numbers. Minus 9.81 times 3. So this will give me something. And that something is 9.81. I know, shocking. Can you guess what is that V for? Yes, it's minus 19.62, which is the magnitude of the velocity that we started with. Remember, they are going like this. So if they reach at the same level, the U will be equal to V. The only difference between them is the direction. So U will be positive. V going downwards is a negative. Okay, so the V4 is 19.62, and my graph is wrong because I need to make space for a negative value. So let's just add that here roughly. So 19.62 is what I started with at 1 second, which is V1. I am a 19.81 around here, possibly. Here was my initial at 1 second, at 2 seconds, and can you guess, at 3 seconds and at 4 seconds. We have a negative gradient. Our acceleration is just gravity. Now I can't draw a straight line. Help me, please. Okay, so I cheated a little bit. I did this off camera. So we have 19.62 for V equals to 0 because that is our U. And then at time 1, it was a 9.81, a positive. And at 2, the velocity is a 0. And at this guy over here, time equals to 3, it's a minus 9.81. And this gives us the negative acceleration, which is equal to 9.81. If you don't believe me, you can calculate it yourself. And I think that is it for our example. See ya!